Math, lesson 11, more elapsed time stuff. So this one is just a good diagram. So I included it for you to see. So if you look at the clock on the far left, it's saying that it is 1:50, so 10 minutes to 2 o'clock. And it's giving you two different elapsed times, like indicators here. So if you drive for 20 minutes to get to the zoo, then you stay at the zoo for 2 hours and 15 minutes, and then you leave. What time do you actually leave? So if you look at where the start time, 1:50, this illustration is saying go in order. Add your 20 minutes. So 20 minutes would be at, right now would be 2:10. Then you're going to add, in this case, that 15 minutes, so 5, 10, 15, so that would be 2:25. And then the illustration here is saying, all right, now that you got the minutes, then you add 2 full hours, it would be 4, which is showing on this clock, and the 25, which is showing on this clock. So if we had Judy clocks at school, that's what we'll be using. Now, this one is doing the same problem with the number line. Now, this is a little more my style because I like to bump or jump those hours first. So if you look, start is still at 1:50. So if you make those two jumps, it'd be 2:50, 3:50. And then I would add on that 20 minutes, which I haven't done yet, and that 15 minutes, which I haven't done yet. So, and I might even combine those and say, well, I'd take 10 of those minutes and make this a 30, and then I'd have a 5. So it's 20 and 15 is 35, just because it's an easier thing. And then because I'm at 3:50, I'd really break that 30 into a 10 and a 20. Because if I had 10 minutes, I'd get to 4 o'clock. If I had 20 minutes, I'd add 4:20, and then I'd add that 5, 4:25. So you look at the first problem that you guys have in the book. Same kind of idea. So Mrs. Cox is getting on a train at 1:45 to visit her grandchildren. The train trip is 35 minutes, 10 minutes waiting for a cab, 15 minutes in a cab. What time does she get there? You really have two different options. Some people would say, okay, let's take that 35 and that 10 and that 15 and find out how much time that is. So you'd have 30, 40, 50, 55, 60, which is 1 hour. And for this one, it makes it kind of nice. So if you're saying if she leaves at 1:45, she has to do these 3 things, which are an hour. What time does she get there? Well, 1:45 plus an hour is 2:45. That one worked out kind of nice. Number 2 is saying, okay, she's leaving home at 9:45. She gets home at 11:20. This one's a little bit tricky because you have the start time, you have the end time, and it's saying she had 55 minutes of time spent at the gym, and the rest of the time is at the library. So first thing I would do is figure out, first of all, the elapsed time. So 9:45, an hour would be 10:45, and then I can't go to 11:45 because that's too much. So what I do know is if I add plus 15, it'd be 11 o'clock. And then plus 20 would be 11:20. So I have 1 full hour, plus 20 plus 15. So 1 hour and 20 minutes, 1 hour and 30 minutes, 1 hour and 35 minutes. Now I have to think of what is the difference. So if I were to take 55 of those minutes and give them to the gym, how much time is left? So I'm just more like an Anna Lang, where I'd say add up. Plus 5 would get me to an hour, plus 35 would get me to an hour and 35. So if I take those 2 times, she must have had 40 minutes at the library. because 40 minutes and 55 minutes is going to be equal to an hour and 35 minutes. Puzzle Penguin, never correct. So that one you got to read, figure out what the Puzzle Penguin did wrong. I like this visual because it goes back to our learning in fractions, and it takes, a circle, or we always talked about it as like a pizza or a pie, and cuts it into fourths, and then it puts it into a clock. So each of those fourths is 15 minutes. So in a clock, it's 15, 30, 45, 60, because we have 60 minutes in an hour. So I like this visual too. So there you have 15, 30, 45, 60, or a full hour. Now you take that and we start talking a little bit different because it's adding fractions. So if Erin jogs for a quarter of an hour, how many minutes does she jog? That would be a quarter of a clock, which is 15 minutes. Here it's talking about 3/4 of an hour, and it's giving you a start time. See, it's a little bit trickier. Now on the very last page, 298, it's actually getting you still elapsed time, but the time in this case isn't hours and minutes. We're talking years, which is 12 months, 365 days. You have 7 days in a week, 24 hours in a day, 60 minutes in an hour. So you have to actually start to kind of translate these. So if Victor lived in Albany for 2 years and 3 months, how many months did he live there? Well, if 1 year equals 12 months, 2 years would have to be double that, so 24 months, and then we can't forget those 3 months, so 24, 25, 26, 27 months. Forgot my age. All right, good luck.